This is 4.5 of part 2. We're going on to graph the cosine function and its parent function. So we're going to focus on the same domain as the sine function to find those ordered pairs. So we're going to split up into 4 equal parts. So we're going to start with 0 again. 0 degrees, 0 radians. What ordered pair on the unit circle is 0 degrees? 1, 0. So we're going to take the x value, which is the cosine, and it is 1. Pi over 2. Over 0, up 1. So what's the cosine of pi over 2? 0. Now we're over to 180 degrees, or pi. Cosine of pi is negative 1, 0. So cosine, the x value, is negative 1. Then cosine of 3 pi over 2, or 270 degrees. 0. And then 2 pi. 1 over 1 up 0, so our x value is 1. All right. So now let's go over and graph this on our xy plane. Again, same x-axis, y-axis, 0, 2 pi, and then our 4 equal parts. It's more common to graph these in radian measure than degree measure when we do these also. All right, so let's graph those ordered pairs. So what's the first ordered pair? Over 0, up 1. Then pi over 2, up 0. Then pi over 1, pi and negative 1. 3 pi over 2, 0. 2 pi and 1. Back to where we started. That is 1 revolution. Notice the difference in where we start the parent function for a cosine. We start at the top of the amplitude, and then we do that same pattern. So if we wanted to continue it, where would it go next?
Down.
Back down, and then back up. What if we want to go this way? Down, and back up. Okay. I'm just going to focus on the red. So we need to understand that revolution and that period. So the distance from, let's call it in black, from here to here is how much? That black segment. How long is that? 2 pi. That's my period. How long it takes for a revolution to occur. Then, amplitude. How big is the amplitude? Yep, the height of the wave is 1 unit. All right, the domain. What is the domain? Any restrictions on the domain? Nope, same as the cosine or sine function. So again, negative infinity to infinity. What about the range? Very good. Negative 1 to 1. Period. Same distance, length of 2 pi, and the height is 1. All right. Those are our 2 parent functions. Definitely write down this slide. We're going to refer to these pieces for a sine and a cosine function. There is one transformation that I'm not talking about today until Monday. It's when you shift left and right. So I'll introduce that piece on Monday, so you won't have any assignment problems like that. So the red piece helps us to tell how tall the curve is. That's the amplitude. And you cannot have a negative amplitude height. So you always take the absolute value of that A. Well, in the sine and cosine function for the parent, the number was 1. So that's why the amplitude was 1. The period is how quickly the revolution occurs. The equation we use to check for it is 2 pi over b. And our b value in the parent functions, if I go back to this slide again, this is my b value, was also 1. So 2 pi over 1 is 2 pi. And you'll have these two things memorized by the time you finish the homework assignment today. You'll know how to find the amplitude and period very quickly. The other two pieces are when you have reflections and when you have translations up and down, picking up the graph and moving it up, picking up the graph and moving it down. When you have reflections, you would have a negative A. And we'll show you those later in the graph. That's when reflections happen, when you have a negative A. The other piece is when you have a D, a piece in the D, in the equation. If you have a plus D, think about my whiteboard at the beginning of the school year when we talk about all the transformations and reflections and things from the parent function. I ask you to memorize those. They come back to play again. The plus D picks up the graph and moves it up that many units. And the minus D is when it moves down that many units. And that's the last piece of this slide. And like I said earlier, I'm not introducing translations left and right until Monday. So what we've done so far is introduced how to graph the parent of the sine and cosine function and what are the pieces to find those transformations, reflections, changes in the amplitude, changes in the period, changes in moving up and down. So now we're going to go ahead and just give you some examples on what the equations would look like and how do you graph them and what you'll do in your homework today. Alright, so let's graph this one first. The function 3 sine of 2x. And before I ever go out and graph any sine or cosine function, I take apart the pieces in the equation to help guide me through the graphing of the problem. So I have 4 pieces that I'm focusing on. The A, the B, the amp, and the period. So what is the A value here? The A value. 3. This is my A value. So then what the A value does is tells you how tall the sine function will be. So we always absolute value the A. So what is that? Quick, 3. Good. So that means we'll have a distance of 6 units total on the y-axis. Then, what's the value of the b? What's the b value? 2. That's always what I call inside the function. So that's 2. So how that helps me is to find out how long the revolution occurs. So in that previous slide, to find the period, it's 2 pi over b. You do need to have that remembered for any test quiz. So 2 pi over 2 is pi. So it's going to take a distance of 1 radian pi to do a revolution. So it's going to take a shorter amount of time for that cycle to occur. So now let's go out and graph it. And we're not going to have you go out and make that XY chart anymore and find all those ordered pairs. We're going to have you do kind of like what we were doing on the parent function, but apply the transformations instead to the parent function. So what I do is make sure there's no translations up and down. In this case, there's no plus or minus d, so I'm set to go. I'm going to graph 3 up, and then I go the other way, 3 down. So my graph of my curve has to curve between that distance, from -3 to 3 on the y-axis. Then, there are no shifts left and right, which we don't talk about until the next lesson. So we're going to start at 0, and we're going to do 1 revolution for a distance of pi. Then all I do is I just split up into 4 equal parts. So what's the halfway point between 0 and pi? Half of pi, or pi over 2. Halfway between 0 and pi over 2. Pi over 4. So pi over 4, 2 pi over 4, what would this be? 3 pi over 4, 4 pi over 4. So let's graph that revolution. On quizzes and tests, we're going to ask you to graph 2 revolutions every time. So you may want to get in the habit of it today when you're doing your assignment. All right, so remembering where in the sine function, the parent, does it begin? I say in the middle of the amplitude is the way I remember it. So it's going to start here. No reflections going on. So it's going to go to the top, to the middle, to the bottom, to the middle. There is my sine wave with 1 revolution. So this distance from here to here is a period of pi. This distance from here to here gives me my amplitude of 3. Let's continue it. You could go in a negative direction if you wanted, or you could go in a positive direction. More students tend to want to go continuing positive, because this does go on forever. So I'm just going to change colors and we'll do 1 more revolution. So I need to add on how much more to get another revolution? Another piece of the pie. So 2 pi. So split it in half, and then half again. So we know we have pieces in fourths. So 4 pi over 4, 5 pi over 4, 6 pi over 4 reduces to 3 pi over 2, 7 pi over 4, then 8 pi over 4. And then you just continue the pattern. Where am I going to go next? Up to the top, back to the middle, to the bottom, to the middle. There is another revolution.